Alright, welcome back for another Green Ninja Climate Science Series video. In this video we're going to be asking the question, why don't CO2 and temperature correlate perfectly? And what I mean by correlate perfectly is that if you look at graphs of CO2 or other greenhouse gases over time versus temperature, you'll see that they don't go up and down necessarily directly with each other. So here's a graph of global temperature represented by these bars and also CO2 concentration superimposed on top of that. And you see that CO2 concentration from the year 1880 to around 2010 has been increasing pretty steadily and has been increasing faster in recent decades than it did in the earlier part of the record. And you see the temperature has also increased over that time period. But if you look at the decade-to-decade time scale, you see the temperature has gone down and then up pretty abruptly and then gone down a little bit and then more recently up pretty abruptly. And then if you just look over the past decade or so, it's been relatively flat despite the fact that CO2 has increased. And so I want to ask the question, why is this the case? Why is temperature not just perfectly following CO2? And does it mean anything if we have a slight decrease in temperature or a pause in warming while CO2 is going up? Well, the first important thing to note is that CO2 is not the only thing causing changes in the Earth's energy budget. And in fact, greenhouse gases themselves, so CO2 plus nitrous oxide plus methane plus chlorofluorocarbons plus other greenhouse gases that humans are putting into the atmosphere. All those together are still not the only thing causing changes in the Earth's temperature. So here we have a comparison of the Earth's temperature as recorded from instruments back to 1880 and a climate model calculation of what the Earth's temperature should have done if it was only responding to greenhouse gas concentration. So that's what this red line is. And we can also show what the Earth's temperature should have done versus what it really did if the Earth's temperature was only responding to anthropogenic aerosols. So anthropogenic aerosols are just particles that are thrown up into the atmosphere from various human activities that actually cause cooling. So they reflect sunlight back to space and cause the Earth to cool. So if only anthropogenic aerosols were affecting temperature, then the Earth's temperature should have decreased over this time period instead of increased. If only volcanic eruptions were causing the temperature to change, then the temperature should have been relatively flat, but whenever there's a big volcano, it should dip down. And so there's been some big volcanoes in the second half of the 20th century that should have caused some big dips in temperature. And if only solar activity was controlling the temperature, then it should have been a little bit cooler early in the 20th century and then a little bit warmer later in the 20th century. So you see that none of these graphs really match what has actually been observed in the temperature record. But if you add them all together, if you include all the greenhouse gases and anthropogenic aerosols and volcanic eruptions and solar variability together, you get a calculated temperature from a climate model that matches the observed temperature pretty well. So the first answer to why CO2 and temperature don't move up and down together perfectly is that there's a lot of other things you have to consider. So CO2 and other greenhouse gases are causing warming in the long run, but you also have to consider aerosols, both from volcanoes and from human emissions, as well as solar variability. And when you do, you get a much better representation of temperature. Now, there's other ways that the temperature can change other than these factors. So there's something called internal variability, which means that the Earth's temperature can kind of change itself on shorter timescales. So this mainly happens by the Earth kind of randomly redistributing heat down into the deep ocean and then sometimes letting that heat back out up into the surface, causing the Earth's globally average temperature at the surface to change without actually changing the energy budget at the top of the atmosphere. So just for the sake of argument here, I want to show how this might work. So this is totally made up data, and what I'm showing is that the Earth's climate is a little bit chaotic on the time scales of year-to-year variability. So here's made-up data from the year 1800 to 2099, and I'm showing that without human activities, the Earth's temperature might go up and down on a year-to-year basis like this. And plus, we're going to add to this some type of a multi-decadal variability, or just variability in temperature that spans multiple decades at a time. So in the real climate system, there's no perfect sine curve variability like this, but this is, again, just made up data for the kind of sake of argument. So let's say that in the natural climate system, without humans increasing greenhouse gases, that you would add these two things together to get what temperature would look like. And so you add these together, you get essentially this, where you have you have variability from decade to decade, and you also have this short-term variability from year to year, and this is what the temperature would have done if greenhouse gases had not been increasing. So now let's think about what would happen if you do increase greenhouse gases. So now here is what the temperature would do if it was only responding to greenhouse gases and nothing else. So if we add that to what we previously had for what the temperature would have done without any greenhouse gases, what do we get? Well, we get all three of those influences. So we have the year-to-year variability, we have the decade-to-decade variability, and we also have this long-term increase in temperature due to greenhouse gases. So you start to see that just because the temperature has stopped rising, in this case from 1956 to 1995 about, this does not mean that all of a sudden magically greenhouse gases have not been increasing the temperature. All it means is that natural influences have been causing cooling over that time period and canceling out some of the warming that would have occurred due to greenhouse gases. So again, this is all made up data. It's only to make the point that natural influences can cancel out warming from CO2 over short time scales. And so that is another reason why CO2 and temperature don't correlate perfectly. But in the long run, they will end up. In the long run, increases in greenhouse gases and CO2 will cause the temperature to go up.